Hi, grade 10s, Mr. Van Horn here. We're going to look at this mixture problem as a way of learning more how mixture problems work. So it says here a store owner sells peanuts for $4.80 per kilogram and raisins for $2.40 per kilogram. They decide to mix the peanuts and raisins and sell the mixture as a snack for $3.36 per kilogram. Yum. How much of each do they need to make 100 kilograms of the mixture? So we got some peanuts and some raisins going into this mixture. The price that they have in mind is $3.36 per kilogram. And so we have to figure out, well, how much? Is this a 50-50 mix? Is it maybe 40-60, maybe 100, or pardon me, maybe 10 and 90 to make the 100? So let's get into this problem. It is a word problem where a linear system is going to help us. And so, remembering this recipe that we learned about the other day, these are the steps that we're going to follow in order to come up with the answers for this problem. So step one, identify the unknowns in the problem. Well, we're trying to figure out how much of each. How much of each what? How much peanuts and how much raisins. So here we go. So mass of peanuts and mass of raisins. I'm going to use P for peanuts and R for raisins. That's going to help remind me what these variables represent. So that's step one. And step two, done. On to step three, create two distinct equations using the information given in the problem. Okay, so the first equation that I'm thinking is that the mass of peanuts plus the mass of raisins needs to add up to 100 kilograms. So they need to make 100 kilograms. And so P plus R equaling 100 is a good first equation. We need to make a second and distinctly different equation. This one's going to be much harder to make. So what do we know? We know that peanuts is $4.80 per kilogram, raisins $2.40 per kilogram. The mixture is going to be $3.36 per kilogram. If you're thinking that all of these numbers are going to end up in this equation, along with the variables P and R, as well as an equal sign, you've got all the right thinking. Now, how exactly is it going to look? Well, it's $4.80 per kilogram for peanuts times the number of kilograms, or the mass of the peanuts, plus $2.40 per kilogram for raisins multiplied by the number of kilograms of raisins needs to equal $3.36 per kilogram of the mixture times the number of kilograms of the mixture, which is not a variable. We know that it's 100, right? They're looking to make 100 kilograms of the mixture. So this equation looks a little different than other ones we were building for the number problems and the value problems, but that's why mixture problems are a little bit different than those. We now have a system of equations that we need to solve. So now that we've done step three, we now need to get into solving the linear system. So I'm looking at these two equations, and it does look like elimination could work very nicely, right? I could multiply the first equation by something to even up the amount of variables. Let's go ahead and do that. I'm going to multiply the first equation by 2.4. That's going to even up my amount of r's. So let's see here. Multiply equation number one by 2.4. When I do that, the equation becomes 2.4p plus 2.4r equals 240. Equation number two, I'm going to keep just as it is. I'm not going to change it at all. So it's still 480p plus 240r, which, you know what, I'm going to refer to it as just 2.4r. And I'm also going to just back up and just start calling this 4.8p. It'll just make looking at the numbers a little bit easier. Equals, and I'm going to do this multiplying, 336, right? 3.36 times 100 is 336. I'm now ready to add or subtract these equations as needed. This is a subtracting situation to eliminate the r's. So I end up with negative 2.4p, and over here I end up with negative 96. Dividing both sides now by negative 2.4, we end up with p equaling 40. So what does that mean? Well, p represented the mass of peanuts. Oh, I guess we're saying that there should be 40 kilograms of peanuts in this mixture. Certainly seems reasonable. I mean, thinking about possible answers, the answer should definitely be somewhere between 0 and 100. So 40 could totally be right. I'm now going to figure out the mass of raisins. So I'm going to sub p equals 40 into number 1. That's the much easier equation to work with. And that gives me 40 plus r equals 100. So r equals 60 kilograms. Everything seems good. I mean, those answers totally seem reasonable. So checking off number 4, solve the linear system. I used elimination for this one. Step 5 is to check. Step 6 is to state your solution. I'm going to fit my checking in over here on this side. So I'm going to do a left side, right side check for the first equation. I'm also going to do a left side, right side check for my second equation. Let's just make sure that everything is working out okay. So p plus r and 100. And the other one is 4.8p plus 2.4r equaling 336. So let's make sure. P is 40, r is 60. Okay, we're not surprised. It worked fine for the first equation. Let's see if it works okay for the second equation. So 4.8 times 40 plus, bad planning, Mr. Van Horn, 2.4 times 60. And when we run that through our calculator, we get some very good news. All that does work out to 336. Yay! That means we must have the correct values for P and for R. So that leaves us with our final step, which is to state your solution. So remembering this is a word problem and that context matters when we make our final sentence, I think our final sentence better refer to peanuts, raisins, and mixture so that it's specific to this word problem. So therefore, the mixture should contain 40 kilograms of peanuts and 60 kilograms of raisins. Yum, yum. All right. So there is a good example of a mixture problem, grade 10s. All right.